Welcome to this exciting tutorial on implementing physics in gaming using Box2D. Today, we'll explore one of the most popular physics engines used in game development, particularly for 2D games. We'll go through the fundamentals of Box2D, establish a simple physics world, and even create some interactive objects. Let's get started. First, let's understand what Box2D is. Box2D is an open-source physics engine that provides robust features for simulating physical interactions. It allows for realistic movements and collisions, which are essential in game design. Now, to get started, make sure you have Box2D set up in your Java project. You can find the Box2D library in various Java game development frameworks, or include it directly in your project. To include Box2D in a Java project, you typically add the dependency to your build tool. For instance, if you're using Maven, modify your pom.xml like this. With Box2D included, let's create a basic physics world. Here is how you can set up the world in Box2D. In this snippet, we first import the necessary classes from the Box2D library. We create a world object, which takes in gravity and a boolean that indicates whether bodies are allowed to sleep. A sleeping body doesn't need to be updated and can save computation time. Next, let's add some bodies to our physics world. In Box2D, a body can represent physical objects that interact with each other. Here's how to create and add a static ground body and a dynamic body that will fall due to gravity. In this method, we first define a ground body using bodydef and place it at coordinates 0, -10. Then we create a ground shape using polygon shape, representing a rectangle. We also define a dynamic body positioned at 0, 4, that will fall when simulated. This dynamic body is defined with a density and friction, which affects how it behaves under gravity and when it interacts with other objects. Now that we have our bodies in place, the next step is to update our physics simulation in a game loop. Here's how you can implement a simple game loop that advances the physics world. The update method calls the step function of the world, updating the state of all bodies according to the physics simulation. The time step is crucial because it determines how often the simulation is updated. A 60 Hz update calls for a time step of approximately 1/60th seconds. You also want to specify the number of iterations for velocity and position calculations, which help increase the accuracy of the simulation. Let's put it all together and see how our physics simulation looks. Here is an example of how you typically structure your main class along with the rendering logic. In the game class, we set up our JFrame and instantiate the MyPhysics world, creating the bodies we've defined earlier. We utilize a timer to call the update method approximately 60 times a second. The action performed method updates the world and invokes repaint, allowing us to refresh the display. The paint method is where you would add your rendering logic to visually represent the physics simulation. At this point, we have a basic physics engine set up with Box2D. However, rendering the bodies is crucial for visual feedback. Box2D works with physical properties, but we need to draw the shapes to the screen. Let's add some rendering logic to our paint method. In our drawBody method, we iterate through the fixtures of a body. For each fixture, if it's a polygon shape, we get its vertices, transform them into pixel coordinates, and draw the polygon on the graphics context. The transformation helps map Box2D coordinates to screen pixels, allowing for a better visualization of physical objects. Now, let's call this method inside the paint method to render our bodies. After implementing the drawBody method, update the paint method as follows. This updated paint method will loop through all bodies in the physics world and call drawBody to render them. We're almost there. Now you should see a rectangle falling due to gravity when you run the application. As a next step, let's incorporate user input so we can add dynamic bodies on mouse clicks. This will allow us to create interactive elements in our physics world. We'll modify the game class to include mouse interactions. We add a mouse listener to our game class to listen for mouse-pressed events. When the mouse is clicked, create dynamic body is called, which sets up a new dynamic body based on the mouse coordinates. We adjust the coordinates to match the Box2D world scaling. This way, whenever you click on the window, a new rectangle will fall into the world. Next, let's add more dynamics by implementing contact listeners that will respond when our dynamic bodies collide. This will allow us to create interesting interactions between objects. In this setup contact listener method, we create a contact listener that allows us to respond to collision events. You can implement specific behaviors within the overridden methods for begin contact, end contact, pre-solve, and post-solve. This enables a dynamic interaction environment in our physics-based world, enhancing gameplay experience. Let's now incorporate these elements into our game class. Make sure to call Setup Contact Listener during the initialization of your physics world. Now that we have a basic contact listener set up, you can implement behaviors such as changing colors on collision or applying forces based on impacts. You will find that both game design and the feedback it provides will be richer and much more engaging. Lastly, let's optimize our simulation by using more advanced features of Box2D, such as setting shapes and joints. This will complete our basic physics engine setup. In this create joint method, we define a revolute joint that allows the connected bodies to rotate around a point. This is useful for simulating complex mechanics such as pendulums or rotating objects. By linking various bodies with joints, you create interactive and engaging objects within the physics world. So far, we have covered the essentials of Box2D, exploring how to create a physics world, add dynamic bodies, update the simulation, handle user interactions, and define collision behaviors. The world of game physics is vast and can be incredibly immersive with just a bit of creativity and understanding. Don't forget to test different shapes and bodies to see how they behave under various conditions. Experiment with joints for more complex interactions. Thank you for following this tutorial on implementing physics using Box2D. If you found this video helpful, please like, share, and subscribe for more content. Happy coding!